Okay, let's talk about natural selection here. Natural selection, we know, is the changes in gene frequencies over time where we're going to see the strong will survive and reproduce in there. So we have three modes of our natural selection, which is stabilizing selection, directional selection, and disruptive selection. And so these are going to kind of explain why natural selection occurs in different stages. So we have our stabilizing selection, which favors phenotypes at both ends of the phenotypic distribution. So this is actually selecting a small range of variation within here. And then we have our directional selection. This favors individuals at one end of the phenotypic range, most common during at times where you have evolutionary change or you have moving of new habitats. And then we have disruptive selection. This favors an extreme or intermediate phenotypes. This occurs when your environmental changes favor the extremes for those. So here's directional selection within blackbirds. And so we can see the blackbird population for beak death here has changed. And you can see where we can have an upset or changes within that population here where we're selecting for that medium one during those dry years. And then the wet years, we see that go down. With disruptive selection, we're going to the extreme. So you're either going to have the really huge beak that you see right here, or you're going to have this smaller, more narrow beak. But you're not going to have both, or you're just selecting for those. So when we talk about stabilizing selection, this kind of favors the middle. So we see this one occur a lot within infants. And so stabilizing selection, we'll see in human birth weight, babies are very large or very small at birth, are less likely to survive, and babies that are in that medium or narrow range are going to have a better option of surviving. So an example of this, you don't want to have a 1-pound baby, but you don't want to have a 14-pound baby. You kind of want to be in that 7 to 9 range. Those babies are going to be healthy and they're going to survive. And actually 6 to 9. Those are usually your really healthy babies and they don't have as many problems. And so let's look at some of these graphs because you'll be graphing a little bit tomorrow. So here we go. With directional selection, we have a mouse population here. This is our original population of mice. We have all the phenotypes showing up here from light fur all the way to dark fur. We have a beautiful bell curve occurring. This is what you would see in a population or a normal population. That bell curve is going to change basing on natural selection. So in the first one, or A right here, we can start to see that we're going from the largest original population, which is the medium colored mouse, going to the darker colored mouse here. And we have a directional change. The bell curve is still staying the same, but it's changing towards that. Then we have a diverse, our B. We're having that disruptive selection where we're not favoring the tan middle ones anymore. We're favoring either the dark or the very light mouse. And then on the bottom, we have our stabilizing selection. We're going to see reduction in the very light colored mouses and the very dark colored. And we're going to see a more of an increase in this tan color because they're the most likely to survive. Now, this week you will be doing a lab that's going to have you use Fruit Loops to kind of go through and recreate these three graphs based on your gene pool frequencies.